Hey, welcome back. And now we're actually going to get into the law that I find more exciting, and it's the law of cosines. I mean, law of sines is fun and everything, but law of cosines is where I think it gets really fun and exciting. Now, when we're using the law of sines, we always had to know angle and its corresponding side, right? We either needed to know both sine A and side A, or we needed to know sine B and side B, or we had to know sine C and side C, right? We had to know big A, little a, or big B, little b, or big C, little c. What if we don't have a pair? What if it's not a right triangle? And what if we don't have a corresponding angle on its side? The law of cosines. Do, 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 do. The law of cosines will come to our rescue. This one's a little trickier to memorize. Again, we have to have a triangle. Again, it is not a right triangle. So there's no hypotenuse, there are no legs. And I can write the law of cosines in three different ways, depending on if we want to play with or find angle A, or angle B, or angle C. If we know angle A, or if we need to find angle A, I will use this version. If I know angle B, or if I have to find angle B, I can use that version. If I know angle C, or if I need to find angle C, I'll use that version. All right, they're all the same format. It just depends on, well, which one you're looking for. Okay, can I use the Pythagorean theorem? No, I don't have a right angle. Can I use SOHCAHTOA? No, I don't have a right angle. Can I use the law of sines? No. The only angle I know is angle A, and I do not know the corresponding side. So I cannot use the law of sines. So what should we find first? Do, 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 do. We know big A, we know lowercase b, we know lowercase c. So we need to go looking for lowercase a. I don't have much choice in the matter, right? I know lowercase b, I know lowercase c, I know angle A, and of course knowing angle A is what really forces me to use the one that has cosine of A. Okay, so plug in the variables we know. We know that lowercase b is 23. We know that lowercase c is 26. And so I get 23 squared plus 26 squared minus 2 times 23 times 26. And then, of course, we knew capital A was 114, so I got cosine of 114. Whew. Make that calculator smoke the way you start hitting the buttons on this one. I got to figure out what on earth is 23 squared, what on earth is 26 squared, what on earth is 2 times 23 times 26. Thank you, thank you, thank you, calculator. Hey, I've got a couple of terms I can add. I can take that 529, that 676, add them together. Now, Sillyville, where students often go off track, is that they really, really, really want to do a subtraction right here. They're looking at 1,205, and they see that subtraction symbol, and they're so tempted to subtract. Problem is that 1,196 is being multiplied by cosine 114. Right? So we were able to combine like terms on the previous step, But now we got to think about order of operations. I must do the multiplying or dividing before I can do the adding or subtracting. Right? I have to actually multiply 1,196 times that cosine of 114 degrees. So I find the cosine of 114 degrees, and I multiply it by our value. Now notice the cosine of 114 degrees came out to be a negative value, and negative times negative comes out positive. I can add those two together, and then if I take the square root, I've got side A, about 41.1. I add that to my diagram. Oh my goodness, I know angle A and I know side A. I can use the law of sines, right? I can say, hey, I can make this a lot more straightforward. I don't need that big, long, super duper cool law of cosines. I can switch back to law of sines now, because I know capital A and lowercase a. So I can compare the sine of 114 to 41.1. So if I want to figure out angle B, well, let's multiply both sides by 23. Punch buttons on a calculator in the correct order. I now know that the sine of angle B is about 0.5112. So if I want angle B, I just do the inverse sine function, right? The arc sine function. Those are interchangeable. I can call it inverse sine. I can call it arc sine. Again, making sure I'm set for degrees, and the answer is about 30.7. I can add that to the diagram. Hey, I know two angles. We know how to get that third angle. They add up to 180. Right? Missing angle has to be 35.3. Right, previous slide. I'm sure some of you thought, no, wait a minute here. A negative value. Cosine is negative. You're like, what? What on earth could possibly be happening here? I thought all the sides of a triangle were positive. And so any ratio of sides will come out to be positive. We're just in unit number 9, folks. We're just playing with triangles at the moment, and so it's probably mystifying how we could possibly get a trig ratio with a negative value. Now, of course, if we were in a right triangle, we would never find ourselves going even as high as 90 degrees, right? Because the acute angles have to be less than 90 degrees, right? Greater than 0, less than 90. And so when we're trapped between 0 and 90 degrees, yeah, sine, cosine, tangent all came out to be positive. But notice that 114 degrees is greater than 90. Oh, it looks like we're back to normal. No more cow wars. We just got our worksheet and we got our cows walking by. Yeah, we got a whole week out of cow wars. That was kind of exciting. But now we're back to our usual ending. No cow wars. No. So we'll just have a nice little worksheet here.